Okay, for 2.6, we are looking at ratios and proportions. Hey, ratios, you guys, is essentially how you are graded, right? A ratio is simply a comparison of two numbers by division. So, like, it's basically a fraction, right? Where we're comparing two things by division. In your grades, it's like the amount that you got right goes on the top over the total amount of points, which would go on the bottom. So it's a ratio, really. Your grade is kind of a ratio. It's just like what are you getting correct out of how many points are possible. Um, and we can get into a whole side note on grading and some of the logistics that go into grading that go above and beyond this. But essentially, if you're on a quiz and the quiz is worth 6 points and you get 5 correct, we're going to call that a ratio. And the ratio is basically you'd say you get 5 correct to 6 possible, right? So 5 divided by 6 would give you some kind of percentage or some kind of decimal number that we can convert to a percentage by moving our decimal. Okay, so that's just a ratio. A proportion, on the other hand, so that's a ratio is a comparison of two numbers by division. A proportion, on the other hand, is an equation. So there's an equal sign with proportions. Okay, so proportions have an equal sign. It's when two ratios are equal. We call those proportions. So here I used a half and a 2/4. A half is the exact same thing as 2/4. I showed that in a previous lesson with some pizza examples. But anyway, that is a proportion. So proportion happens when we have equal ratios. Okay, so we have an equal sign. So it says here, determine equivalent ratios. Basically, to determine if you have equivalent ratios, for example, one, you guys, all I really need you to do, I'm going to teach you two strategies ultimately, but what I want you to do for now is just simplify each of the fractions. So, for example, 1, work on simplification. Can you simplify either of these? And hopefully you're seeing that this guy can be simplified, this one cannot. If you simplify 6/10, by simplifying, what I mean is there a number that I can divide both numerator and denominator by that's the same, that's in common with both? So is there a number that is that I can divide both 6 and 10 by, is essentially what I'm looking for. So here, that number is 2. Okay, so if I take 6 and divide it by 2, I get 3. If I take 10 and divide it by 2, I get 5. So 3/5 is an equivalent fraction to 6/5, or sorry, 6/10. It is not, however, equivalent to 2/5, and that's what they're asking. It says determine if 6/10 is equivalent to 2/5. No, because if I reduce 6/10, I get 3/5, and 3/5 is definitely not equal to 2/5, right? So that's 1A. 1B is very similar. Okay, so here 1/6 cannot be reduced, but if I take 5/30 and ask myself what goes into both, the answer is 5. If I divide by 5 over 5, I get 1/6. So 5/30 is the same as 1/6. Is 1/6 equivalent to 1/6? And hopefully you're at home saying yes, of course it is. Okay, so these are equivalent, and the way that I got that was just reducing the fraction. But now I want to teach you another way. It is the cross products. So in a proportion, you guys, the product of the extremes is equal to the product of the means. What this means is if you have a proportion like A over B equals C over D, then A times D will always equal B times C. All right, and that goes back to kind of this idea up here. If you took 5 times 6, it is equal to 1 times 30, right? So anyway, there's a lot of ways that we can prove this, but for now, we're just going to learn the rule that cross products exist when we have an equal sign between two fractions. That equal sign is very, 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 very important. I see people try to do cross products with multiplication all the time. So like, I see people doing this, 2/3 times 1/4. How do I solve that? Oh, I do that cross multiply thing. No, You don't. Okay, if you're doing this, you're multiplying straight across, right? So you get 2 over 12. But if you were to say 2/3 is equal to 1/4, which it's not, you would do a cross multiplication, right? So 3 times 1 is equal to 2 times 4. Since we all know that that is not the case, then these are clearly not equivalent fractions, or proportions for that matter. So this is what this is talking about. Cross products happens. We use cross products whenever we have two fractions that have an equal sign between them. So here we go. Let's look at example 2. It says use the cross products to determine whether these pair ratios forms a proportion. So are these proportional? But what I do is I take 0.2 over 1.8 and I set it to equal 1 over 0.9. If I do this out, okay, this one was a little tricky. If you do this out, you get 0.18 when you multiply 0.2 times 0.9. And then you get 1.8 if you multiply 1.8 by 1. So even though these look very similar, I don't know why they're trying to trick you here. They look very similar. They're not. One's 0.8, one's 1.8. So therefore, the answer to this is no. These are not equivalent. All right. The other way I could do it is I could take 0.2 and divide by 1.8 on my calculator and get the decimal. And then take 1 divided by 0.9 on my calculator and get the decimal and compare decimals. That's another way we could be doing this. For 2b, it says use cross products to determine whether the pair of ratios forms a proportion. Okay, so is 15 over 36 equal to 35 over 42? So we can cross multiply these guys. If I take 36 times 35 and then 15 times 42, I believe when I do this on my calculator, I get something like 630 is equal to 1260, and that is not the case. Therefore, no, these are not equivalent. Okay, so there's a couple examples for you. For example 3, it says solve the proportions with variables. So it's saying basically that these are proportional, and then we can solve these by setting them to equal each other. So r over 8 is equal to 25 over 40. We're going to use cross products to solve. So we have 8 times 25 is equal to r times 40. 8 times 25 is just 200, is equal to 40r. And then divide both sides by 40. And I get r is equal to, one of those goes away. 20 divided by 4 is 5. So we have, we just have 5, right? 40 times 5 is 200. Okay, so r is equal to 5. So one way that we can check this, you guys, is we can say, okay, if I take 5 divided by 8 on my calculator, is that equal to 25 over 40 on my calculator? You should be getting the same decimal for both when you divide those out. Let's look at 3b. So again, we're going to assume that they're proportional, so we're going to just cross multiply. So I get 8 times x plus 4 is equal to 5 times 3. Okay, if I do this out, I get 8x plus 32 is equal to 15. Therefore, 8x is equal to 15 minus 32, which I believe is negative 17. So then x is equal to negative 17 over 8, or negative 2.125. Okay, the last little bit, you guys, is this. It says solving rate work problems with proportions. So what I'm trying to prove to you guys here, or like get you to understand, is whenever you're setting up these ratios, you always want to make sure you have the same relationship in the numerator and denominator. So if I say something about miles per hour, okay, that should be equivalent to another miles per hour. All right, so make sure your units are the same. So here we go. For example 4, let's take a look at this. It says it takes 7 minutes for Isabella to walk around the gym track twice. At this rate, how many times can she walk around the track in a half an hour? So I want to make sure that I keep minutes to times around very clear. Okay, so it stays consistent throughout. So what I'm going to do is I'm going to look at this and say, okay, 7 minutes to walk around twice, right? So 7 minutes to 2 times around. The X is kind of confusing, so let me just say 2 times. Okay, so what would it be for 1 time? I always like to relate this to 1. So if I related this to 1 time, I would divide by 2 on both sides. 7 divided by 2 is, hopefully you're saying 3.5. So it's 3.5 minutes per 1 time around the track, right? So it says, how many times can she walk around the track in a half an hour? Okay, so if I'm going 3.5, if I'm going 1 time around every 3.5 minutes, what I can do is I can take that 30 minutes and divide it out by 3.5, right? So I take 30 divided by 3.5, and that will tell me approximately how many times I can walk around that track, or Isabella can walk around that track in a half an hour. So let's really quick do that. So we take 30 divided by, what was it, 3.5? And we get 8.57. Okay, so this is 8.57. Oh, what did I write? 6.57. Or we can just say like 8.6 times. All right, so that's example 4. Example 5 says, on a model airplane, the scale is 5 to 2, 5 centimeters to 2 meters. If the model's wingspan is 28.5 centimeters, what is the actual wingspan? Okay, so there's a couple ways we can do this. We can figure out what it is for 1 and then use that little conversion. Or we can just say, okay, 5 over 2, 5 centimeters over 2 meters is equal to 28.5 centimeters over, we can just say x meters, and then cross multiply. Right, so 28.5 times 2, let's just make sure that I get that correct here. So 28.5 times 2 is 57. Okay, so I get 57 is equal to 5x, and then x is equal to, let's divide both sides by 5 here. So I take 57 divided by 5, and I get 11.4. And I am done, I believe. Oh, and I probably should label this, right? So, oh, and this is x. So on a model airplane, the scale is 5 to 2. If the model's wingspan is 28.5 centimeters, what is the actual wingspan? This would be 11.4 meters, correct? So, that's pretty big, actually. So if a meter is approximately 3 feet, so that's pretty good size, like 33 or something feet. 33, 34, 35 feet, something like that. But it's 11.4 meters is the answer to that one. All right, guys, that's it for this lesson. We'll see you guys in class, and we'll work a bunch of these together.